And welcome everybody. It's great to have you. My name is Keith Barker. I'm a double CCIA, and this channel is 100% focused on the techniques and topics and technologies around CCNA, and currently that flavor is 200-301. It's great to have you. I had a request to do a packet tracer lab on SLAAC, not the teamwork app on the internet that people use on their computers, but rather the stateless address auto configuration facility that is involved with IPv6. So I thought, well, before I do a lab and a packet tracer lab that gives you a chance to practice it, I probably ought to spend just a few minutes here in this video sharing with you how it works and what our options are, and then give you an opportunity to see how it's configured, and then we'll follow it up with a packet tracer lab. So without further ado, let's talk about why we'd use automatic address assignment of any type. Imagine we have 200 or 300 clients, PCs, devices, mobile devices, laptops, desktops, servers, and everything else. If we need to assign all those addresses manually, that takes a lot of work. So in the world of IPv4, we use a feature called DHCP, the Dynamic Host Configuration Protocol. We know it, we love it, and it's very effective in giving lots of people the correct IP addresses, along with options like their default gateway and the correct DNS server to use and so forth. Well, in IPv6, we also have the option of using DHCP for version 6, but we have a couple different options beyond just DHCP. One of those is SLAAC. Let me share with you a topology, and then let's talk about some of our options, and I'll walk you through how to configure it and verify it as well. So let's use this whiteboard right here. And let me go ahead and bring a pen up. I'm not sure what it is, but I dial everything in for the presentation. Then at the last minute, like, oh, I'm going to need a pen. And there's a pen. All right, so with IPv6, the option of stateless address auto configuration, also known as SLAAC, here's how it works. You go to your device, whether it's Linux or Windows or Mac OS, what have you, and there's going to be an option for IPv6. One of those options is auto config. And if you select auto config, what it's going to do, it's automatically going to get an IP address on the network. And you might ask, well, how in the world does it know what network it's on? And here's how it works. We take this router interface right here, and it has an IP address, and we enable the router for IPv6 unicast routing. So if it's a Cisco router, that's literally the command you do. So we have an address here, and automatically that router, if it's IPv6 unicast routing and it has an IPv6 address, it's going to issue what's called a RA, a router advertisement, periodically. And basically then in that router advertisement, it says, hey, this is the network. And you know what? In fact, I've got one. Let me hide that pen for a moment, and let me show it to you. I just captured it about 10 minutes ago. And it is somewhere close. Let me bring it up. And there it is. Okay. So let me bring this in and just check the screen to make sure we can all see it. Great. All right. And let me minimize that as well. All right, thanks for your patience there. So this right here is a router advertisement from a Cisco router that has IPv6 unicast routing enabled. And so right here it says it's a router advertisement. And router advertisements in IPv6 leverage the protocol of ICMP. So down in this router advertisement, it's advertising a lot of information, including the network or networks it's connected to. So what this says right here is that this piece right here of the router advertisement indicates, hey, this is the 2001 DB8678357 network with a 64-bit mask. That's what's in this router advertisement. And so when a PC connects to this network and says, I want to do auto config, it can go ahead and do a solicitation. It's called a router solicitation. It's asking, hey, any routers out there? So that goes out to FF02::2. That's the IPv6 multicast address for all routers. So a client says, hey, what network is this? I'm asking for basically a router solicitation, which would trigger a router to issue this router advertisement. So we don't have to wait 200 seconds or whatever the interval might be. We can just go ahead and do a request. We get this advertisement from the router, and then the PC looks at this address, this network, and says, oh, this is the street. That's the 64-bit network that I'm on. And then it will go through the process of automatically configuring a host address for that subnet. And it also goes through a process called duplicate address detection, just to make sure he or she is not going to use the same exact host address as somebody else on that network. So the default router information and how to get off the network, all that information can be learned via the router advertisements. All right, so if we are using SLAAC, that's the mechanism behind it. That's the stateless automatic address assignment or automatic address configuration, this is C there, and that's how the PC works. Gets an IP address just by doing a router solicitation, finding out what the network is, and then creating its own host portion on that network, and it's on the road. All right, so that is also called stateless. From a DHCP, it's stateless because no one's tracking that client. Like, hey, what address did you get? And I'm keeping track of that. If we were using DHCP for version 6, we have an option. I'll put V6 there. We also have an option for stateful. Hey, I can write out here too. I'm keeping all that little box. We could also use with DHCP. We could use stateful, and with stateful, basically it works like IPv4's DHCP, where the client looks for a DHCP server and then gets an IP address assigned by a DHCP server, and then uses that IPv6 address. So stateless is when it does it on its own. Stateful is when a DHCP server hands out the IP address. Now, there is a really big problem with a lot of this, and let me share with you what that is. The problem is, if this client is stateless, using SLAAC, stateless address auto config. In fact, the acronym SLAAC is S and L and A and A and C. So stateless address auto configuration. If it's using that and it gets its own IP address, let's say the client is using, I'll just put in, it's going to have some wacky long host address, but let's for grin say it gets an address. Now the question is this PC ever going to want to use DNS? And the answer is yes. Clients and computers, we use DNS. That's where we can type in a name like a URL like bubba.com or cbtnuggets.com or something else. And behind the scenes, it resolves that name to an IP address. That's DNS. Well, if we're using stateless autoconfig, which we're doing right here, how do we learn DNS information? Now, this is a challenge that's being addressed pretty aggressively, and there's some new standards on saying, hey, this router is doing router advertisements. Why not just be able to tuck in or include that information, the DNS server information, in the router advertisements? Okay, great. When that's standardized and everybody's doing it, it'll be great. However, on a lot of gear, it's not standardized. So, but we still need this PC to use the DNS server, and we don't want to have to manually configure that. So one other solution is this. We could tell the PC, yeah, go ahead and do auto config, but we could also tell the PC, for your address, use auto configuration, but also go ahead and use DHCP for the other options. And when I say other options, I mean things like a DNS server or a domain name or other details that client may need to use. So it's like a split. The client's looking at the address, the network, and doing auto config for its IP address for IPv6. And then it can reach out and go to a DHCP server and say, hey, I don't need an IP address. What I need is other information, such as the DNS server to use. And the way we control that, this is interesting. The way we control that is we have the router in its router advertisements play with two flags specifically for this. Now these flags are labeled M and O. Not 0, but O. And the M means managed. And here's how it works. In fact, let me show you one, and then I'll show you how it works. I've got a capture of that also. I did it about 45 minutes ago. Just got out my packet analyzer. And, okay, so in this graphic right here, in these flags, currently everything's set to 0 for the flags. And so if the flags are set to 0 for managed, this means if it's 0, the client, when it sees that router advertisement and it sees this managed flag to 0, it's not set. That tells the client, hey, you're on your own regarding getting an IP address. If the managed flag is set to a 1, an on, that means to the client, hey, you need to get your IP address from a DHCP server, along with any other options that DHCP server may hand out to you for IPv6. The other option here is this guy right here, which is the O. So that's the O flag for the other configuration. So if the managed is set to 0, which means you're on your own, get your own IP address, figure it out from the router advertisement, but we have the other bit, the other configuration bit set to 1, that's what tells the client, okay, I'm getting my IP address on my own, but I am going to go ahead and talk to the DHCP server and ask them about the other options, such as, hey, what DNS server should I use? That's it. That's how the M and O bits work inside the router advertisements. So let me clear that off. And also let me show you what a couple of these look like. So So this is a router advertisement with the O and the M bits off. I think I have another graphic here. Here we go. Here's another one where I have the M bit set to a 1, which means hey client, you see this router advertisement? I know the network's here, but what I want you to do is I want you to go ahead and get your IP address assignment from a DHCP server, which would be stateful DHCP for IPv6. And then I have one more, and that has the O bit, or the M bit is not set, which tells the client, get your own IP address, figure it out, and from the network prefix I'm giving you in this RA, and the 1 in the bit set for other says, go ahead and contact a DHCP server, and we'd have to supply what that DHCP server is, to go ahead and let me back off that just 1 second. So the other, I'm getting too far ahead of myself. So the other bit, if it's set to on, means configure your own IPv6 address, and then go ahead and use DHCP services to learn other information like DNS. So the question is, how do we control a router to force it to set the M bit to a 1 or set the O bit to a 1? And the answer is we do it in router configuration if it's a Cisco router. So I'd like to, in fact, I can just put those, in fact, let's do this. If you've got Packet Tracer version 7.3, or, because I know it's supported in 7.3, maybe even older versions, let me show you how you can configure the interface and verify that it's actually working as indicated. And that'll give you a nice walkthrough if you want to practice this on your own. So we'll practice setting up the router. We'll set up the IPv6 interface. We'll enable IPv6 routing. We'll enable no bit set for the M or O. We'll enable the M bit, and then we'll enable the O bit, and that way you'll have a full range of motion on how to configure it. All right, so let's bring up Packet Tracer. And survey says, there it is. So blank screen, blank canvas, green field. So you can start just like I am right here if you want to practice this. And let's go ahead and grab, click on routers, and let me grab a 2911. Boom, right there. And let's go ahead and click on, so we could put a switch in there, or we could just take a switch. Yeah, the switch isn't going to buy us much, so I'm just going to go ahead and take a PC and use a crossover cable to go ahead and connect it directly to the router. And that's the kind of cable we would need because they're both expecting to talk to a switch, but we're having to talk to each other, so we use a crossover cable. And let's go to the router, and let me slide this over here. And for our plan, let's use this. Let's use this address right here, 2001 DB8678320::, and we'll use 1 for the router. And then we'll use auto config for the PC. All right, back to Packet Tracer. Here we go. All right, so at the router, let's make that window a little bit bigger. Let me check my feedback monitor here. All right, looking at, well, that's too big. All right, let's make it a little bit bigger. Great. We'll click on the CLI, and we'll say, no, we don't want to do the initial configuration dialog, and I'm not going to do too much more than just the basics of what's needed here. So config T interface gig 0/0. We probably should bring it up. No shutdown. Good start. And let's do a set up the IP address on gig 00. IPv6 address 2001 DB8 6783. Let me check the IP address. 20. Okay. So we'll put in 20 here. : 1 with a /64-bit mask. Boom, we've got an IPv6 address. Now let's do a do show IPv6 interface gig 0/0. And check this out. This says, here's my global address that we just configured. Fantastic. Here's its link local address that it automatically configured. Non-routable, just good for the local link it's on. And it joins some multicast groups, including FF02::1. That's everybody who's speaking IPv6 is a member of that multicast group. Oh, and what he hasn't joined yet is he hasn't joined the all routers multicast group. And that's because we didn't enable IPv6 routing. Let's do that next. So if we do I'm going to go back to global config IPv6 unicast routing, and then now let's do a do show. I'm doing the do just because I'm in configuration mode. Do show IPv6 interface for gig 0, not GIF, gig 0/0. And now check this out. It's now joined the all routers multicast group, which is great. So now if somebody does a router solicitation, they're going to send it to that multicast group for all routers. Then the router can hear it and send a router advertisement, including the network information. Also, right here, check it out. All these down here and below, it's all showing that we're now doing router advertisements because we're doing IPv6 unicast routing. Fantastic. Let's go finish our config. where were we? Interface gig 0/0. We'll do show run just so I can look at the config. All right, so there it is, IPv6 address. And okay, so right now we're doing router advertisements. But what we're not doing is we're in the router advertisements, the M and the O bits, they're all set to zeros, meaning we're telling the client, if the client gets an IP address, they're just going to do SLAAC on their own, and or they see these RA messages, they'll do SLAAC on their own, and they won't have DNS information. It won't have a DHCP server assigned IPv6 address. The client will do it on its own, and we can verify that too. Just go to the client, and here on the client, we'll go to config, and we'll go to fast Ethernet 0, and we'll say right here under IPv6 auto config, and it's done. If we go to settings, oh, look at this. It also has an IPv6 default gateway, which is R1. Or not R1, it's router 0. We didn't rename him R1. So this PC is good to go. If we go to the desktop and go to a command prompt and just do an IPv6 config, that's a little thing in the emulator here in Packet Tracer, IPv6 config/all. There's its link local address, there's its IPv6 address, there's this default gateway, which is the link local address of the router, and it doesn't have a DNS server at the moment. So this is an example of stateless auto config and not using DHCP services in any way. Now, if we wanted to, what we could do is we could configure a DHCP server, and then we could tell the client with the router advertisements, hey, the O bit, the other configuration information is set to a 1. Go ahead and get DNS information from the DNS server, or get the DNS server information via DHCP. Now to do that, let me walk you through it. We'll simply, well, first of all, if we're going to use DHCP to provide options to a client, we need to have a DHCP server. And so I only have one router right here, so I'm going to create a pool for an IPv6 DHCP server where we can include the DNS server information so we can have the client get it from us. So let's do IPv6 DHCP pool, and we'll call this our pool. Not my pool, not your pool, our pool. So we're going to call our pool, and we have some options here. Oh, well, DNS server is all I want to add here. Let's say the DNS server is 2001 ABC1 2 3 : 5. I just want to make sure that when we see it, we'll say, yeah, that's the DNS server we're handing out. So now we have this pool, this IPv6 pool. We're not specifying a network address. All I want to do is hand out the IP address or the DNS information from the DHCP pool. Now to go back and actually make this work, we're going to go to interface gig 0/0 and say IPv6 DHCP server ? Now on live gear, there's also an option called automatic, which means it would automatically find a pool. But in this case, we're just going to refer to the DHCP pool we just created, which was called our pool. All right, and let's do a quick show. Do show run. And I run so far away. Okay, so there's our pool with the DNS server in it, and there's our gig 00, and it has an IPv6 address. It has IPv6 DHCP server our pool. If we go back to the client, and I'm just going to bounce the client physical. There should be a power button here somewhere. Oh, there it is, right there. Click off. Click on. And as it powers up, let's go back to config and fast Ethernet, and let's put it back to auto config. And let's go back to desktop, and we'll do an IP config, IPv6 config /all. All right, so it's still getting its own IP address with SLAAC, but check it out. No DNS server. It's not learning a DNS server. Why is that? Did you catch it? The answer is, on the router interface, I did not specify whether or not to set the O bit to on. And as a default, they're all off. If we go back and look at this packet capture I did a few moments ago, right here. So we need this other the O bit set in the router advertisements, but currently without any tweaking, what we have is this. We have the managed address flag, which is saying, hey, get your IP address directly from a DHCP server and all the other options. It's off. And the O flag is off, which means, hey, you're on your own for IP address, but we need to go ahead and have you use DHCP to get the other options like a DNS server. And by default, all these bits right here, the M and the O bits are off. So here is the secret sauce in training the router to set the bits for M or O to an on. So if we do M, we're set for configuration of an IP address and all the options. If we set O, the client's on its own for IP addresses, and the client will then go to the DHCP server for the other options, including DNS. So let's go back to the router, and here's how we're going to do it. Just to make sure we're on the right interface. Always a good thing. And we're going to do this, IPv6, a question mark, and it is ND. ND stands for neighbor discovery, space, and here is how you set those flags. If you want the M flag set to on, which tells the client to get an IP address from a DHCP server, that'd be stateful DHCP. We're going to use the manage-config-flag, and that turns the M bit on. If we want just the O bit on, we'd use this option, other-config-flag, and that's what we're going to do here. So let's do a up arrow key, other, and we're done. Let's do a show run. So we have our pool, but it doesn't have any, all it has is DNS information, the DHCP pool. And then we have, in gig 00, we're specifying that that's the pool we want to use or be available to us. And then here we also have the other bit, or the O bit set with this command here. So what should happen is the client should be on its own for an IP address, but it should also go out to a DHCP server for the other information, including the DNS server. Let's test it. All right, here on PC 0. All right, so see how here it still says no DNS server. Let's do an IPv6. Haven't tried this yet. Let's do /renew. Oh, it didn't bark. So let's go ahead and hit the IPv6 config space /all. Yep, still doesn't have a DNS server. Here's what I'm gonna do. I'm gonna bounce that bad boy. I'm gonna power him off, power him back on. Also, what we could do is just go to the config fast Ethernet and force it between static and auto config, and that should break it loose as well. All right, so auto config is set. If we go up to global settings and auto config, I don't see the DNS server right here. Well, let's troubleshoot. Let's make sure I've got my details set up on the router okay. So show run. So I've got my pool, the DNS server. That's all I want in there. And it's called our pool. And it is a DHCP version 6 server, not IPv4. And on gig 00, I have IPv6. Oh! Did I do it on the wrong interface? I don't see the other config sitting there. Maybe I was in... See, I don't see it. Let me go ahead and put it in. Config T to show history. Not hittery, history. So that's my configuration history buffer. Right there. I set it. I set that command. So I'm going to right click, copy it, interface gig 0/0, and paste. And then do show run. All right, it's definitely there now. I'm not sure what happened. It was I'll take the hit for that one, but it wasn't working and the config wasn't there, and that reinforces it. So now that that's done, let's go back to our client, and we'll go to static for a moment. Actually, I'll go to fast Ethernet, go to static, and then auto config, and then just take a peek under global settings, and there, look at that right there. Our DNS server shows up now. And if we go to desktop and we do a IPv6 config. I powered it off and on back since then. And we'll do a IPv6 config/all and check it out right there. There's our DNS server. All right. Well, that was fun, and the little extra troubleshooting was not intended, so that was a little extra bonus. All right, so quick summary of this discussion. SLAAC is the automatic address assignment for a PC or a computer on an IPv6 network. It's going to look at it's going to do a router solicitation, gets a router advertisement, looks at the advertised prefix, the network, and then says, great, I'll go ahead and create my own host ID on this network, sets it up, make sure it's not already in use with DAD, duplicate address detection, and then starts to use it. The challenge is it doesn't have the other options, including things like, what DNS server do I use? I configured my IP address on my own. So what we can do is we can have that information in a DNS server or in a DHCP server, the DNS information in a DHCP server, and then use the other bit set on the router interface so that when the client sees it, it says, oh, I'm going to do autoconfig for my own IP address, but I'm going to reach out to a DHCP server and ask for the other information, including what the DNS server is. All right, so there's an opportunity to understand what that is and how it works, and also a little practice in Packet Tracer if you want to implement. Also coming up, I have another lab that's going to focus on SLAAC and DNS information being learned via DHCP. So if you want a full lab to practice with, stay tuned for that one as well. Also, I want to point out that as you study for your CCNA, I realize, as a double CCIE, I realize that the CCNA is not the end-all be-all to everything you'll ever need to study. But I can guarantee you this, if you want to work in networking, having the knowledge from the foundation of CCNA is a great idea. So if you don't have it yet, I encourage you to pursue it, get it as a stepping stone on the way to your full career and journey. And then after CCNA is done, then take a look at the next logical step, and the next logical step, you just keep on learning. So CCNA is a component in your journey in the world of Cisco or in the world of networking. And I'd love this channel to be an additional resource for you and support in that aspect of your CCNA. And then as you master that and keep on going, just don't stop learning. All right, it's been super fun chatting with you and talking with you about the SLAAC and the autoconfig and the M and the O flags in IPv6 router advertisements. And I'll see you, my friend, in a very next. Keith, you were doing so good. I'll see y'all. Also, by the way, if you enjoyed this video or learned something from it, give it a like. And if you haven't already subscribed, please subscribe to be alerted when we have new videos that come out. And I'll see you in the next live event here on the Keith Barker channel. Thanks, everybody. Have a great rest of your day.